In this video, we continue with the Computer Science 9618 AS level curriculum, taking a look at logic gates and logic circuits. So this is actually part 2 to the part 1 video where we talked about how all the different gates worked. So we're going to be looking at some practice problems. Now, is it possible there can be more than 2 inputs? Here's how your truth table should be set up when you have 3 inputs. So we have A, B, and C. There are 8 possible combinations. So here's how you set it up. With A, we're going to put 4 zeros followed by 4 ones. With B, we're going to do 2 zeros followed by 2 ones, 2 zeros followed by 2 more ones, and then in C, we're going to alternate 0, 1, 0, 1 all the way down. That will set up every single possible combination for 3 inputs. So that is how your table should look, and that is the table we're going to be looking at as we dive into these practice problems. Now, in math, do we have a specific order in which we do the operations? And of course we do, and here in the US we call it PEMDAS. Now you may be saying, but all I saw in that first video was addition with the OR sign. Well, the AND gates, they represent multiplication. So what if you have the following, A and B or C? Which operation do you handle first? Do you do the B or C and then AND that result with A, or do you do A and B and then OR that result with C? Well, multiplication happens before addition, so I would do A and B, and then I will OR that result with C. So here's what I mean. Let's take a look at this diagram. In this diagram, I have A and B or C. So I have my A input, I have my B input, and I have my C input. Right here is my AND gate, and I have to handle this before I handle the C. And that is because in math, we do multiplication before we do addition. So down here's my OR gate. So what's going to happen is A and B are going to come through this AND gate, and then I'm going to have the result, and this result is going to be going through the OR gate with C. And then that's going to give me the output. Now, when A, B, and C are all off, the output is going to be 0. So let's talk about why. So A would be 0, B would be 0, C would be 0. And when 0 and 0 go through an AND gate, the output is 0, because in order for it to be 1, both of them have to be true. So now I have 0, which is from right here, and I have this 0, which is from C coming in. When 0 and 0 go through an OR gate, the result is 0, giving me an output of 0. So that is how the logic circuit would be built. You have to do A and B, and then you want to OR that result with C. Now, let's fill out the truth table for this exact formula. So we have A and B or C. Now, this is what we call the workspace. You don't necessarily need the workspace. It is not graded when you're in Cambridge. However, as you do more and more of these, it'll be you're not going to need the workspace at all. But for this one, let's look where A and B are both 1. So here, this doesn't work. This one doesn't work. This one doesn't work. I'm looking for where A and B are true. This one doesn't work. But here, A is true and B is true. Here, A is true and B is true. So I know for a fact these are going to work. So I'm going to go ahead and put a 1 there, because the result, the output is A and B, or it can be C. So now what I'm going to do is I'm going to go through and I'm going to find all my C results. So here's C, that will work. Here is C, that will work. Here is C, and that will work. C's here, but I already have a 1 here. What do I do with these blank spaces? I know these do not work. And now I've accounted for every single possibility for A and B or C. Let's go ahead and move on. So let's try this one. Well, what if we have A or C and B or C? Which ones do we handle first? You're going to handle what's in parentheses first. So we're going to do A or C first. Then we're going to do B or C, and then the result of A or C, we're going to end with the result of B or C. So when you're trying to set up your logic circuits to draw them out, you may want to ask yourself, okay, How many OR gates do we need? Well, I see that there are 2 OR gates. How do I know that? Because I see one plus sign and I see another plus sign. So I know we need 2 OR gates. How many AND gates do we need? Well, I'm looking for that dot and I see that dot right here in the middle and I know that I need 1 AND gate. So that is what I would use to build my logic circuit. I would put those to the gates. But let's take a look at some practice problems here and understand how to draw these. So this is from a past Cambridge exam. So here they want us to draw a logic circuit, which is not a problem. But let's break down and see what we're looking for. If A is not 1, so the key word there is not 1. So I know that's going to be A with a line over it. Then it says OR. Okay, well, I know I have a plus sign. B is 1. So I know I have not A or B. And I'm going to put that in parentheses because that's in parentheses. And I'm going to AND that result with C. So I'm going to draw my AND symbol. I'm going to put that with C. And I probably shouldn't have written that crooked. Let me just rewrite it over here. So we have not A plus sign B. And that is going to be ANDed with C. Okay, now we have this OR. So I know I'm going to do this whole thing. I'm going to OR it together, but let's handle those parentheses first. I have not B, because it says B is not 1, and C. So I'm going to do this, and then what I'm going to do is I'm going to OR these results together. So we can do whichever parentheses we want first. I'm going to go ahead and do the first one. So I have not A. Well, I know I need a NOT gate then. So I'm going to draw my NOT gate. I'm going to put that little circle on the end. And I'm just going to draw a line from A right into that NOT gate. So that'll be NOT A. Remember, we said the NOT gates only have 1 input. Now I need to OR that with B. So I'm going to draw my OR gate. So here comes that result. I'm going to OR that with B. And I need to AND it with C. So I'm going to draw my AND gate right here. Make sure it doesn't look like an OR gate. And I'm going to take this result and I'm going to AND it with C. That takes care of this one right here. But now I need to handle this, not B and C. So what I'm going to do is I'm going to draw my NOT gate right here. And what you can do is you can branch off the existing line. So what I'm going to do is I'm going to draw a dot right here to let my examiner know, hey, I'm branching off of B. And that's perfectly acceptable. So I'm going to draw a line to this NOT gate. And then I'm going to have my AND gate. I'm going to draw this right here. And then I'm going to branch off of C just so my examiner can see that. And that takes care of this. There's only one thing left to do. I need to OR it together. I need to OR these results together. So I'm going to draw my OR gate. And then what I'm going to do is just connect my wires so they can see that I've ORed the result together. And then it goes to X and we are done. So that is how you draw a logic circuit. Now, most of the time when you draw a logic circuit, you're going to need to also fill out a truth table. So, you also may have to make a logic statement. This right here is a logic statement, what I have outlined in green. So basically you're going to say X or our output is 1 if, and then you use words instead of symbols. We talked about those Boolean expressions. What we had here was a Boolean expression right here. This is a Boolean expression. When we put that into words, like what they have here, that is a logic statement. So if they ask you to write a logic statement, what you're going to do is, instead of using symbols, you're going to use words. The only symbol you really should be using are those parentheses. Let's go ahead and move on, and let's take a look at another practice one. So this one is from a past exam. So a wind turbine must shut down when certain conditions are met. The 3 variables and the conditions which dictate their values are shown in the table. So we have wind speed, we have oil pressure, and we have motor temperature. And we have those binary values, 1s and 0s. And I need to pay close attention to that. So it says the logic circuit is to be designed where the output X is 1 if So we're always looking for where the output is going to be 1. We're not looking for where it's going to be 0 because we're looking to see when the output is going to happen. So I have either, and that's fine. It's going to be one of these. How do I know it's one of these? Because I have these ORs. That tells me right away, hey, we're going to need some OR gates, which are plus signs. So let's take a look at this first one. Wind speed is greater than or equal to 100 kilometers per hour. So I know right here that has a binary value of 1. How do I represent W as a 1? Just W. That's it. And then it says and. Draw my and symbol here. And you don't have to write out the formula. Writing out the formula, though, makes it so much easier to draw your logic circuit, which we'll be doing in a minute. And it says oil pressure is normal. So I look at my oil pressure. Oil pressure is low is a 1. Oil pressure normal is a 0. So how do I represent P as 0? That's going to be not P. And then I'm going to OR it together with this one. Motor temperature is greater than or equal to 50 degrees. So that is going to be a 1. Motor temperature greater than or equal to 50 degrees Celsius. That's going to be a T. They want me to AND it together. So not a problem. And then it says oil pressure is low. My oil pressure being low is represented by P as a 1. So that's simply going to be T and P. And then they want me to OR it together. So I'm going to put another OR gate. And then it says wind speed is less than 100 kilometers per hour. So here's my wind speed is less than 100 kilometers per hour. That's represented by a W, which is 0. How do I represent a W as a 0? Not W. And then they want me to AND it together with motor temperature greater than or equal to 50 degrees Celsius, and that is this value right here. Motor temperature is greater than or equal to 50 degrees Celsius. That is represented by T. So now I have this, and because I have this formula, it'll make it so much easier for us to draw our logic circuit, which we're going to need to do on the next slide. So you may want to go ahead and pause the video here, go ahead and copy down this formula. That way you can see what we're working with. I'm going to copy it down too and write it on the next slide. So let's go ahead and take a look at how to draw this logic circuit. We have our formula written out. Remember, we have to deal with the ANDs before we do the ORs. So we're going to deal with these 3 first, and then we're going to OR the results together. So we have W and not P. So I'm going to have an AND gate. I'm going to have not P. So I'm going to go ahead and draw my NOT gate. I'm going to put that little circle on the end, and I'm going to put P into here, and then I'm going to AND it with W. And just like that, we are 1/3 of the way done. We just took care of this. Now we want T and P, so I'm going to draw my AND gate. I'm going to put T there, and I'm going to put P there. Draw a circle here. That's not really a good circle, but it'll let the examiner know, hey, I'm branching off of there. And then we need the not W and T. So we're going to do this. And you can really draw it wherever you want. It doesn't have to be in a specific order. We can draw a nicer circle. And we're going to AND that with T. So what I'm going to do is I'm going to draw my AND gate here. I'm going to follow this down, branch off of T, and I'm going to draw this here. Now you might be saying, okay, we have a problem because we have 3 AND gates, but we're only going to have 2 OR gates. How am I going to handle that? Very easily. So we can do any of these we want. We're going to do W and not P. We're going to OR that with T and P. So here is my W and not P. So I'm going to go ahead and draw a line coming out of here. And then I need to OR that with T and P. So T and P is right here. So I'm going to bring that up a little bit. And then I'm just going to OR them together. And then I'm going to double check my lines. So we have P branching off. We have T going into here. That's T and P. And then we want to OR that with W and not P. So here's my W and not P, and yes, we do have these lines. So then we need to OR, we have this right here. We need to OR it with this result. So what we do is we draw another OR gate. I'm going to have this result coming out of here because the result of this is right here. This is that result, that wire coming out of here. And then I need to do that with W, or excuse me, not W and T, which is this one right here. And now they have been ORed together. And that leads me to my output. And I just picked up 7 points. Now we need to take a look at filling out the truth table. So what we're going to do again is we're going to copy this formula over and take a look, checking for each one of those. So let's go ahead and take a look at our truth table, and let's take a look at the formula written with the truth table. We have our formula here, which makes it very simple to check to see each one working. So we're looking where W is 1 and P is 0 because we're looking for not P. That's the first one we're looking for. So we're looking for where W is a 1 and P is going to be a 0, because when P is 0, what is not 0? It is 1. So that's when we're looking for not P, we're looking where P is a 0, W is a 1. Here W is a 1, P is a 0. I know that works because it can be, as long as at least one of these are true, it will work because of the OR gates. Here we have W and not P, so that works. There is no other situation and where the first one right here will work, so I can just check it off. Now, just to know, you do not have to write the formula out on your Cambridge exam to get points, or the Boolean expression here, you do not have to write out. The reason I'm writing it out is so I don't have to flip back and forth between the pages. It makes it much easier. It's going to save me a few minutes on the exam, and you don't have a lot of built-in flex time for your Cambridge exam. So now we're looking for T and P, where T is 1 and P is 1. Here it is right here. That will work. And it works down here at the bottom. So that takes care of T and P. The last one I'm looking for is not W and T. How do I represent not W? That means it needs to be a 0. So I'm looking where W is a 0 and T is a 1. So W is a 0, but T is not a 1. W is a 0, T is a 1. That will work. W is a 0, but T is not a 1. W is a 0, T is a 1. I already have a 1 written there, so that's fine, and that takes care of all of those. So what do I do with these leftover boxes? I know they don't work, so I just throw in my zeros. And you want to do that at the end. You don't want to fill out those zeros prematurely, because then you may have to cross it out and write a 1 there. So we always want to go through, we want to check each expression, and when we have all the expressions and we filled in all the ones, then you want to go back and fill in your zeros. So now that we've done that and walked through, this one's going to be your turn. So go ahead, pause the video here, and we're going to break this down step by step. So after you come back, we're going to have the formula that you should have written out. But go ahead and pause the video. So this is the formula that you should have ended up with. P and T, or not P and not R, or T and not R. Oil pressure is greater than or equal to 3. That gives us a P because P is 1. And temperature is greater than or equal to 200. That gives us the binary value of 1. Temperature greater than or equal to 200. That gives us a T. They want us to AND it together. Or we can have oil pressure is less than 3 bars. That gives us a 0. How do I represent P as a 0? That is not P. We're going to AND it with rotation greater than 1,000 revolutions per minute. That's a 0. How do we represent R as a 0? That is not R. We want to OR it together with temperature greater than equal to 200. That's going to give us a regular T, and they want us to AND it together with rotation greater than 1,000 revolutions per minute, and that is going to be a 0 because rotations greater than 1,000 revolutions per minute is a 0. How do I represent R as a 0? Not R. So that is what you should have gotten. So now let's go ahead. Let's take a look. So let's draw a logic circuit to represent that system. So what I want you to do first is go ahead and write it out, and then go ahead and draw your system. So if you're having trouble drawing this, let me go ahead and walk you through it. The first one we're going to look at is P and T. So I need an AND gate. So I'm going to draw my AND gate, P and T. Now, it doesn't have to be in the same exact spot. Mine is, as long as it matches up. That takes care of P and T. Now we need not P and not R. So I'm going to need a NOT gate. Two NOT gates, actually. One for not P, another one for not R. And I'm going to AND that together. So I'm going to go ahead and draw those here. I'm going to branch off of P because I have not P. Come down here, put that in. Going to have not R, and those are ANDed together. So I'm just going to draw that into my AND gate. And then we have T and not R. So we're going to draw another AND gate. What I'm going to do is I'm going to branch off of T right here. You can branch off from T anywhere you want. And then I need not R. So I'm going to branch off after this wire has gone through the NOT gate. Come up here. We're going to AND that together. Now I have some OR gates. So what I need to do now is I need to OR the results together. So I'm going to OR these two together. I could do the other, I could do not P and not R, or T and not R. I could do those. And then what I need to do is I need to OR those results together. So I'm going to take this result. That's going to be one input. My second input is going to be down here. And just like that, we have to our output. So that is what you should have. Doesn't have to be in the same order that I have it, but you need to make sure that you have all those gates with the right inputs. So let's go ahead now. We're going to take our Boolean expression, which is this right here. We're going to write it down on the next slide, and we're going to fill in that truth table. So let's take a look at this. The first thing I want you to do is go ahead, write down that formula. Take the 15 seconds it does to do that. I keep saying formula, I mean Boolean expression. Take the extra 15 seconds it will take, and then fill out this truth table, and then we'll compare answers. Okay, in case you're having trouble filling out the truth table, we can fill it out together. Hopefully you gave it a shot. The first one we're looking for is where P is 1 and T is 1. Here's P is 1. No, T is not 1. Here's P1. No, T isn't 1. Here's P is 1 and T is 1. I'm going to go ahead and mark a 1 there. P is 1 and T is 1. That one works. Perfect. Now, we're not going to put in zeros here. We're going to figure out what works, and then whatever we're left over with obviously will not work, and we'll fill in those zeros there. So P and T is done. Now, this is worth 4 points, so in a second, we'll talk about how this is scored. So we're looking for not P and not R. How do I represent not P? Well, that means not 1. So we're looking where P is 0 and R is 0. That is what not P and R means, because when P is coming in at a 0, it's going to invert it to a 1. When R is coming through the inverter as a 0, it's going to invert it to 1. So that's why not P and not R, we're looking where both of those are 0. And right here in the very first row, I have P is 0, I have R is 0. That's going to be a 1. Does not work in the second one. Does work in the third one. We have P is 0, R is 0, so that one will work. Will not work in the fourth one, will not work in the fifth one. It doesn't work anymore. So that takes care of not P and not R. The last one we're left with is where T is 1 and R is 0. So here T is 1, R is 0. I already have a 1 there, that's fine. Here T is 1, that doesn't work. Here's T is 1, R is 0. We already have a 1 there, so that's going to be it for that. So we have our working scenarios. We have done all of those. And if there's a 1 in the box, it just stays. It doesn't matter. So now I'm going to put in zeros, and we are done. So you may be saying, well, those are 8 columns. How does Cambridge score my 4 points? It brackets these together, and in order to get your point, you must get 2 of them in a row correct. And that prevents students from guessing. So we got this one right, we got this one right, we got this one right, and we got this one right, picking up those 4 points. I hope you found this video helpful. If you found it helpful, please give it a thumbs up and subscribe to help our channel grow. And we'll see you guys in the next one.